Okay, so let's continue with this one and then we're going to talk about the exam. Okay, what do I need to talk here? Okay, so we've covered like until rolling bodies. And we know that rolling bodies means that it has both the translational, which is it's moving forward ataupun moving backwards. Tak kisahlah XYZ direction. And it also has that rotational motion, which means that the kinetic energy is not just linear kinetic energy, it means that we also have rotational kinetic energy. So your kinetic energy is now 1 over 2 mv squared plus 1 over 2 I omega squared. Now, the thing that you need to know when you're dealing with rotational bodies is that you need to have the I, the moment of inertia. A moment of inertia is dependent on MR, moment of inertia. It depends on the shape, it depends on the radius of the object. Sorry, the shape is the radius. It depends on the mass of the object and also like how sometimes you have bodies that are made out of 2-3 particles and that makes your life easy, but sometimes it's like a whole disk like this. So that's going to be hard to calculate. So the moment of inertia takes care of this and gives you like a bunch of equations that you can use later on. So the moment of inertia for a rolling, we're going to assume this tire is a cylinder. So maybe it's 2 over 5 mr squared, I'm not sure. So moment of inertia is dependent on the mass and also the radius. This is like the basic equation, but this does not hold true for all types of shapes. Kadang-kadang 2 over 3, kadang-kadang 1 over 5. So it depends on your object punya shape. But the basic is it has to have mass and also radius. And then we have omega, which is your angular velocity. So omega can be related to your linear velocity by v equals to r omega. So let's say you have your linear velocity, but you don't know what your omega is, but you have your radius. So what you can do is you can substitute omega for v over r. So if you have your v and your r, you can substitute omega as v over r and you would, manage to get the answer if you have the linear velocity. Okay, so what else did we talk about? Okay, so instead of just having mg over here plus ke, which was the linear part of our E initial, so we talked about conservation of energy in chapter 4, I think. So we talked about conservation of energy whereby if the object or if the motion is not hampered down by a non-conservative force such as friction, so there's no non-conservative work done. Therefore, your EI must be equal to your EF when this object reaches the end of the plane. Now, instead of mgh plus ke, which is ke is 1 over 2 mv squared, now you have two components to your ke, which is 1 over 2 mv squared and 1 over 2 I omega squared. You can write your equation mgh plus ke still, you can. But when you're expanding it, you have to take into consideration that it has the rotational part to it. So your kinetic energy has to have 1 over 2 I omega squared. Sama juga dekat E final, you would have your mgh final plus ke final. When you expand it, becomes mgh final plus 1 over 2 mv final squared plus 1 over 2 I omega final squared. Okay, so at the bottom of the plane, typically we say this is our reference point and h is equal to 0 over here. And at this point, our h is just h. So we can cancel this out as 0 and we're just left with the we're just left with the kinetic energy. At the top part, we typically start at rest. So typically your ke is equal to 0 because at rest is v equals to 0, right? If you have your v equals to 0, does your omega become 0 as well? If my v is 0, is omega 0 as well or not? Come on guys, that's a conceptual question.
0.
0, kenapa? Okay, can we relate?
because
Mm-hmm.
omega is V over R. So if
Yeah.
V is 0, then 0.
Omega is V over R, betul. So if your V is 0, then R is 0. So basically if your object is at rest, dia tak bergerak. So there's no rotational motion, there's also no linear motion. So boleh fikir logik macam tu je lah, okay? Or you can use the mathematical equation to justify that it's not moving because V is 0. You can do that as well. So that is for conservation of energy. And what else? Kita dah cakap pasal, no, not this one. We talked about this table. So we have displacement as when we want to relate it to the angular quantity s equals to r theta, ataupun you can call it x, the same thing. And then we have the linear velocity, kita nak convert jadi angular velocity, so we use the r over here. Okay, so this is how we can convert our linear quantity to angular quantity lah, basically. So if you want to find omega, it is V over R. If you want to find a theta, it is S over R, and so on. And then we have A equals to R alpha, and then we have I, which is the moment of inertia. This is your equivalent to mass in the linear world. So I equals to mr squared, and then L is your angular momentum. Okay, I'm just reminding you here. So if you want to convert ataupun if you want to relate it to linear momentum, there is the R over here. Sama macam tadi tu. Cuma this part is linear, this part is already angular, dia terbalik. Okay, so that is something you need to take note of. And then we have torque, which is R force. Okay, so that is how you convert it into linear or angular, vice versa lah. And then for torque, we also have I alpha. And then for L, we also have I omega. Now, why do we have two equations? Because this equation gives us the relation between the linear quantity. This is linear quantity, this is angular, right? This is linear quantity, this is angular. In this one, they are all angular quantities. So this is L, angular, I, angular, omega, angular. So let's say you are dealing with all the parameters are in angular quantity. So you can use this equation. And if you have linear quantity, you want to convert it to angular, or you have angular, you want to convert it into linear, depends on the problem, so you can use this equation. That's why they have that too. Okay, and then kinetic energy, we talked about this. Work is force times displacement. In the angular quantity, it is work equals to torque theta ataupun torque delta theta. Then power is Fv or W over T, work done over time. And this is in the angular sense, it is torque times omega. Okay, so these are equations that you need to remember. And then we have work kinetic energy theorem. Okay, so if you have a difference, if your object changes in velocity, you know that you would have a change in kinetic energy. When we have a change in energy, we have W net ataupun W total. This applies to anything really. When you have a change in U, G, when you have a change in U spring, when you have a change in KE, you would get work done. But the work kinetic energy theorem specifically focuses on the kinetic energy. Okay, but you can use it for anything else. For angular relation, sama juga, you just convert your M to I and then your V to omega. Okay, and then conservation of momentum, when external force is 0, we learned this before, when external force is 0, the total momentum is conserved ataupun total momentum is constant. When external torque is 0, total angular momentum is also constant. This one, kita belajar yang the spinning ice skater tu. Remember the ice skater, there was no net external torque applied to the ice skater. So therefore, she can, when she angkat tangan and then when she closed her hands, she could spin faster based on the conservation of angular momentum. That was for the ice skater. For linear, I don't remember, but we've learned it before. And then we talked about rolling bodies, and then we are back to where we started. Back to where we ended last time. So we have done this one. We have not done this one yet. Okay, so this is example 8.8. A ball of mass 0.5 kilogram, sorry, and radius 3 centimeter. Okay, so m is equal to 0.5 kilogram and your radius is 0.03 meter. Okay, so this is quite famous example, I would say. By famous, I mean a typical question in the exam. Without slipping, it rolls without slipping down an inclined plane. So you have an inclined plane and it says that this inclined plane is 30 degrees above the horizontal. It rolls without slipping. Does anyone remember what roll without slipping means? What does the slipping indicate? Without slipping tu maksud dia apa?
Does not stop rotating.
It does not stop rotating. That is actually very accurate. It moves and it does not stop rotating at any point. Kalau dia slip, dia tergelincir kan, dia akan slide. Dia slide off. When it slides, it no longer rotates. So that is, there is a break in the rotational motion. But so when we talk about no without slipping, we are assuming that it is constantly rotating while it is moving forward. So we can use the KE equals to 1 over 2 mv squared plus 1 over 2 I omega squared because that is the average. On an inclined plane 30 degrees above the horizontal, if the length of the plane is 0.8, so it's saying that this whole thing is 0.8 meter and the ball starts from rest. So we have U equals to 0. What is its speed when it reaches the end of the plane? So this is synonym to conservation of energy lah kalau kita cakap pasal the speed when we start at rest and then we want to know what is the speed at the bottom. This is like typical conservation of energy problem. Okay, so it moves down here and we want to know what is V over here, right? Okay, so we have two scenarios. One is E initial and the second one is E final. So E initial, I know that I have mgh, and then I know that I will have Ke at some point, but I'm just going to write it down because I want it to be balanced. So I have mgh initial plus Ke initial, that is my Ei, and then it is going to be equal to my E final, which is mgh final plus Ke final. Now it doesn't say that we have friction, so we are going to assume that there is no WNC, okay? So we start with mgh initial. I'm going to expand my Ke. So first I know that it started from rest. So if I started from rest, it means that there's no velocity. So our Ke initial is going to be 0. And when I reach the bottom, my mgh final will be 0 because my h down here is equal to 0. Okay, up here my V is equal to 0. Okay, so now I have mgh initial equals to Ke final. Okay, and then expanding that, Ke, I am rolling without slipping, which means that I have the two components. One is linear, one is rotational. I don't know why I'm stuttering today. 1 over 2 I omega squared. Okay, so we need to know what is the I for our ball, right? So let's go back to our table because I also don't remember. What is the I for a ball? It is 2 over 5 mr squared. Is it a ball or a disc? Let me see. A ball. Okay, it's a ball. Okay, so if it's a ball, it should be a sphere lah. So this is the I for a sphere, 2 over 5 mr squared. Now we go back to our problem. Oops. Where is it? Uh-oh. Okay, it's here. So this is going to be 1 over 2 mv squared plus 1 over 2. I is 2 over 5 mr squared. And then we have omega squared. And I have mg. I don't know what my h is. my H is this guy, right? Because this is 0. So H is over here. So how do I find my H? Anyone? Macam mana nak cari H dalam ni?
Pythagoras.
Pythagoras. Okay. So what should I use? Sine, tangent, cosine?
Sine.
Sine. Okay. So sine 30 is equal to opposite over hypotenuse. So that is H over 0.8. So H is something. I don't know. Okay, my bad. Okay, I don't have my calculator. It's dead. Can someone calculate that for me? What is H?
0.4 meter.
0.4 meter. Okay, thank you. And then we have 0.4 meter over here. So now we have M. We know what M is 0.5. We have G. G is the gravitational acceleration or the constant. And we have our H. So that's great. So it is equal to 1 over 2 mv squared. We're trying to find V. This is our unknown because it's asking us what is its speed when it reaches the end of the plane. So V is like the unknown that we are going for here. And then we have 1 over 2, 2 over 5, m. M, we know that. R, we have the value is 0.03. And then we have omega squared. What should I do with this omega? Anyone?
Change to
V over R.
Change to V over R. Okay, so let's do that. So mgh initial 1 over 2 mv squared plus 1 over 2. I'm just gonna, okay lah, tak apa lah. Kita buat dulu. 2 over 5 mr squared. And then we have V over R squared. Okay, so now I'm gonna try to cancel out anything that I can cancel. Excuse me. Oh, I missed out R here. Mr squared, okay. So apa yang kita boleh potong kat sini So we have R squared, V squared. So R squared, I have R squared here. I can cancel that out. I have, what else can I? So I have M. Can I cancel that out too? Boleh ke tak boleh?
Yes.
Yes, right? So I can factor out my M from these two components. So dia akan jadi macam ni. M 1 over 2 V squared plus 1 over 2, 2 over 5 V squared. So this is what I'm factoring out the M. Okay. So nak tunjuk je. Tak nak tulis pun. So M will be cancelled out. M. Kalau semua ada M memang boleh cancel out. Okay, so now we're left with GH 1 over 2 V squared, 1 over 2, 2 over 5 V squared. So I can add these two guys together because they are just V squared, right? So 1 over 2 V squared plus 2 over 10 V squared equals to GHI. 1 over 2 tambah 2 over 5. Is it 7 over 10? I think so. 7 over 10. So let's write it over here. GH equals to 7 over 10 B squared. Okay, now I'm going to substitute the values here. Tak suka lah warna kat situ. Sekejap. Let me make this smaller. Is everyone following me? Senang ke susah? Ada yang tertidur ke? Senang ke susah? Semua tak nak jawab. Takut
Boleh
lagi.
lah.
Boleh lah. Okay.
Okay je.
Okay. So let's continue our journey. So G is 9.81. H is 0.4. Then we have 7 over 10 V squared. So if I wanted to solve for V, this should be times 10 over 7. Square root that, I will get my V. Don't know what that is. Can someone calculate that for me? What is V?
2.37.
2.37. 2.37 meter per second. Okay, hopefully betul Saya tak tahu. Let's see. 2.37. Yay, we got it. Okay, so dia buat EI equals to EF, mg 1/2. Okay, sama lah. And then finally 10/7 GH. Yeah, looks the same. Why is the 0.8 sign tadi? Oh yeah, dia tak solve. Kita terus dapat 0.4. Kita dah solve this part, so we don't have that sign. Okay, so that's done. So we have covered rolling bodies. So now we're going to talk about connected objects, linear and rotational. Tadi rotational body yang tengah moving. This one is moving too, but we have pulleys, so it's going to be a little bit hard. Okay, so I want everyone to focus. Okay, ready? Ready. Okay, so last time when we talked about pulleys, right? When we talked about pulleys, we ignored. We said, okay, the pulley is does not have friction, therefore tension is the same on both sides, so we can ignore them because basically it's the same thing. But now, despite our pulley still being frictionless, it has that rotational motion. And like last time, we ignored rotational motion if our ball, hello, tak boleh lukis pula. Last time when our ball fell down, we just calculated 1/2 mv squared without the rotational motion kinetic energy, right? Now that we have learned the rotational motion, we have to apply it for the pulley as well. Sad news. Tapi tak apa, kita dah tahu macam mana nak buat. Okay, so previously when we talked about this type of problem, what we would do typically was to draw the free body diagram. So this would be mg, and this would be tension because there's a string. This would be m2g, and then this would be tension, another tension. And we ignored the pulley, right? So now we cannot ignore the pulley. If our tension is T over here, this guy is also T, this guy is also T. And if we wanted to know what is the rotational kinetic energy, or if it has torque, or if it has, I would say tu je lah kot, torque dengan rotational kinetic energy, then we have to draw the free body diagram for this guy as well. Okay, so the free body diagram for this pulley, kita akan tulis all the forces yang ada kat pulley ni, which is tension, and then we would also need to identify what is the radius so that we can find the torque. So the radius will be the same at any point, right? So the tension can be anywhere, the radius would still be the same. Your task is to actually identify the force and make sure that you have the right radius. So if you see over here, they already separated the system into 3 free body diagrams. The first one, tension 1. This is M1G, T2, M2G. This one is T1, and this is T2. If the tension are not the same. Sometimes they are the same. So previously, if we were talking about these 2 free body diagrams, I would say, okay, F net in the Fy is equal to, this is moving, so it is going to be M1, MA, right? It's going to be equal to MA. This is the condition. And then we write down what is in our free body diagram. So this is going to be T1 minus M1G. And this will be equal to your condition. This is the equation that you need to use. And for this guy, we would say net in the Fy is equal to, we're going to say that A is going down. So it's minus MA2, this MA1, sorry. Positive going up, negative going down. And then I would say this is T2 minus M2G, and this will be equal to your condition, which is minus MA2. Okay, so this is what we did last time. This is still applicable for this chapter. We are still going to use it. Right now we have another one, which is net torque. Net torque. There's no X, there's no Y, there's no Z here. It's just net torque equals to, it is rotating, therefore it is going to be I alpha. This is your condition. If it is in equilibrium, meaning to say it's not rotating, equilibrium dia akan net torque equals to 0. Sama je macam net in the Fy is equal to 0 if it is in equilibrium. But if it is not, it is equal to Ma. Okay, so let's continue with this one. Net torque is equal to I alpha. I alpha is synonym taklah synonym. Macam analogous to Ma. Net F equals to Ma. I is M, alpha is A. Ni sama je sebenarnya. Okay, so we have net torque equals to I alpha. This is my condition. What do I do next? I write down my, what do you call this? Free body diagram punya equation. So here, I have two tensions. Both have the same radius R and R. So assuming that they are completely different, one is pulling to the right and one is pulling to the left. The one that is pulling to the right will give me clockwise rotation. The one that is pulling to the left will give me anti-clockwise rotation. So in my equation, it should be positive T1, positive R T1 because torque is RF, right? Minus R T2. This is the condition. This is from the free body diagram, the radius and the force. Torque is RF. The T is your F, the R is your capital R over here. So it's the same approach except that now we are dealing with clockwise or anti-clockwise and then the radius times with the force, okay? So now let's apply it. So here we have two boxes, A and B. It is connected to a pulley and we have one is 5 kilogram, the other is 2. So it's telling us that it is moving to the right. And if it's moving to the right, this guy is also going to move downwards. Excuse me. And it means that this guy will be rotating, what do you call this, clockwise, okay? So free body diagram for A is going to be mg r. If I have friction, I would have friction in the opposing the motion, sorry, and I would have tension here. And then for this guy, the free body diagram is mg and tension. There's no reaction force, it's not on a surface, it only has tension. Doesn't have friction, it's not on a surface, you only have tension and mg. Okay, so if this guy, I would label it as T1, let's label this T1, and this as T2, so this guy would be T1, this guy would be T2, and I need to know what is the radius of this pulley. The end. Tak adalah tadi end pun. Kita kena tulis equation, kena teruskan perjuangan. Okay, so net F, we are assuming that it's moving, or do we want to be in equilibrium? Oh no, it's moving. So net F for this guy is X equal to, it's moving. Let's say this is A, no. This is A, and this is also A, okay? So that is net Fx equals to MA. Okay, net Fx equals to MA, sorry, got distracted. And then I'm assuming if I'm saying that A is positive to the right because kenapa my MA is positive here and it is to the right. So apa-apa yang to the right will be positive. So MA positive, therefore T1 is going to be positive. You have to follow the convention that you created. So T1 is positive minus friction. This is going to be equal to MA. And then you have your net Fy. If you want to write it down, if you don't, then you don't have to. R minus mg. And then this is for system A, sorry, object A. And then for object B, you have your net Fy equals to MA is going down. So let's say it's negative. Anything going down is negative. Anything going up is positive. Okay, so that is your condition. And then you have T2 positive minus M to G. This is M2A, this is M1A. So this is going to be equal to minus M2A. So that is for your object B. And then for your object pulley, kenapa banyak sangat SMS ni, distracted lah. For your pulley, again, something that rotates, make your object rotates clockwise will give you negative, and anti-clockwise is positive. So net torque, I alpha, this is your condition. Whatever that is in your free body diagram, you write it down. So let's say this is R. So R T2 minus is clockwise plus R T1. So this is going to be equal to I alpha. Sorry, I alpha, it's rotating clockwise, so it should be negative. My bad. This is minus I alpha. So this is minus I alpha because we are assuming it's rotating this way, clockwise. We are assuming the object is moving to the right, that's a positive A. This guy moving downwards, that's a negative A. And then we're assuming because this guy is to the right, this guy is going downward, therefore logically it would rotate clockwise, right? So clockwise is negative I alpha. And then your T2 is going to rotate clockwise, is negative RT2. This guy is going to rotate this object anti-clockwise. So RT1 equals to minus I alpha. So the tricky part in torque is actually remembering that you have signs. That's my problem actually. I don't know benda yang confusekan korang, but hopefully that's not it lah, because the signs are very, very critical. Okay, this is the same case. I'm just gonna go over it quickly. So here we have mg, sorry, salah. Jangan ikut saya please. This is mg. This is going to be mg cosine theta. This is also chapter 3. You guys have to revise for chapter 3, right? So this is going to be mg sine theta. Okay. What else? We have R. And then we would have, this guy is moving this way. That's weird. So it's going to be, this friction is going to be this way. Okay. So this, dia bagi, it already gave you this arrow indicating its motion. So it's going to the left. Therefore, this guy has to go, what do you call this, anti-clockwise, and then this guy has to go downwards. So friction always opposes motion. It doesn't matter if your mg sine theta is here, you put it there. You still put it there even though it looks weird. So friction, mg sine theta, you have your mg here or your weight, the same thing. And then you have your mg cosine theta. What else am I missing? I'm missing tension. I have a string. So I have T over here. Okay. And then this one is the easy one, mg, m2g, and we have T. There's nothing else here. There's no friction, there's no m2 cosine, benda ke tak ada lah. Okay, and then you have your pulley system. It is rotating anti-clockwise, so that is good news to us. Net torque is equal to I alpha, positive. And then this, let's say this is T1, this is T2. Do the same thing. This is T2, T1 over here as well. T1 will rotate that guy clockwise. So T1 is going to be negative. R T1 plus R T2. T2 is going to rotate this guy in the anti-clockwise direction. So it's going to get the positive sign. This is equal to I alpha. Okay, I think, okay, good. Any questions so far on the free body diagram? Free body diagram je dulu. Okay tak?
Okay.
Okay, okay, what about the equation? Anyone confused about the positive and negative of I alpha? So everyone's okay? No questions? Kalau ada soalan boleh tanya. It will help your friends. Okay, no questions. Okay, that's good. Kalau ada soalan pun tak apa, you can ask me. Okay, moving on. So now we go into problems. So let's skip this. We know this. Kenapa ni? Tak nak gerak pula. Okay, so this is... After we finish chapter 8, let's take a mini break and then kita akan discuss about the exam. If you have any questions, you can ask me. I'm gonna like reiterate what will be on the exam. Like not like literally lah, okay? Like gist of it. Where's the problem? Okay, so it's this example. A cylindrical 5 kilogram reel. This is a reel. This guy, the pulley lah. The pulley is the reel with a radius of 0.6. So reel, mass of reel, I'm going to label that as MR, 5 kilogram. And then R as 0.6 meter. And a frictionless axle. What is axle? I think it's this thing. Okay, so it starts from rest and speeds up uniformly. So U is equal to 0 and it has some V, but it speeds up uniformly. You know that your A is constant value lah. So you can use the apa nama dia? Linear kinematic punya equation if you wanted to. And a frictionless axle starts from rest, speeds up uniformly as a 3 kilogram bucket falls into a well. So this bucket is connected to this thing, a reel, and then it falls down. So movement dia macam ni. So it has this A going down. And therefore, this guy is rotating this way. Gambar yang terbalik. This guy is rotating this way. Sorry. Okay, so that is our question. So I need to, MB is equal to 3 kilogram. Okay, so the bucket does not have any radius. It's just a bucket. It doesn't have rotational. It's just going down like a block of mass. Okay, anggap macam tu je lah. Making a light rope unwind from the reel. So as the bucket goes down, benda ni tali dia terkeluar lah kan. The bucket starts from rest and falls for 4 seconds. So the time taken to fall is 4 seconds. Okay. So it's asking what is the linear acceleration of the falling bucket. It's asking what is A, what is the angular. So if we can solve for A, we can also solve for alpha because they are related by radius. What is the tension of the spring? T. How far does the bucket drop? So it tells you it falls for 4 seconds. So you need to know what is your displacement or S in the y-axis. Okay, so we already have the free body diagram here. So we have tension and then, so let's draw our free body diagram. So we have M bucket G. We need to make this B smaller. Okay, M bucket times G. What is it? Excuse me. So MBG. So this is your weight, and you also have tension. It's supposed to be a straight line, and then you have it is going anti-clockwise. Tapi gambarnya tu macam ni. Tak apalah, kita buat anti-clockwise je. So it's rotating anti-clockwise because it's moving down here, and we know that this also has the same tension as the bucket. Sebab apa? Tension kena sama on both sides. The direction will be towards the center of the string. That is tension. Okay, so we have one tension, we have the radius. So if we have force and we have radius, we will have torque. And that is going to be equal to I alpha. Okay, so let's write our equation. Kalau soalan, please stop me. As in, please ask the question. Sekejap. No, move away. Okay, picture format. Sekejap. Crop. Now I want to write the equation. Let's use pink. So net F for the bucket. Let's do the bucket first because it's easy. So net F in the y-axis is going to be equal to MA. A is going down. So we're going to define that as negative ke bawah, positif ke atas. So semua akan follow this sign convention that kita create sendiri. Let's say you want to say A is positive as it goes down. Boleh, but everything else has to follow that same sign. So net in the Fy is equal to minus MA. And then we have what is in our free body diagram. It is T minus MBG. This B is supposed to be smaller. So T going up. So based on our convention, we said it is a positive. So it is a positive. MBG is going down, therefore it's a negative. And this equation in the free body diagram will be equal to our condition, which is minus MA. So now if I wanted to solve for tension, let's just say I want to, saya nak just rearrange je. So T is equal to MBG plus, sorry, it's going to be minus MA. I'm moving this guy to the other side, becomes positive. The MA still has that negative sign. So it's going to be minus MA, minus MBA actually. So if you have like two systems, like two objects in one system, your condition has to use the mass of that object. So let's say it's the bucket, it has to be MB. It cannot be mass of the real. You're talking about this object, your condition must be related to the object. Therefore, the mass should be mass bucket. Tak boleh letak MR, salah. You're talking about the bucket right now. So MBA, so minus MBA equals to tension minus MBG. Sama juga macam weight, you can't write MG and letak mass of real when you're talking about the bucket, right? Sama juga macam condition, dia kena letak mass of bucket juga. Okay, so that is your tension. The next one, we have torque. So net torque is going to be equal to I alpha. This is my condition. It is rotating anti-clockwise, therefore it's a positive. What is in my free body diagram? I have one tension only. The other side, there's nothing. Yeah, there's nothing. Assuming there's nothing lah. Okay, we're assuming there's nothing. So RT, sorry. RT, it is a positive because it is also rotating anti-clockwise. So positive RT, that is going to be equal to my condition that I stated up here. So that is I alpha positive. Okay, so I is equal to, what is the I? I don't know. It is a cylinder. Let's go back to the table. Okay, so we have this one, we have this, and we have this. Which one represents the real, the best? A, B, C, D. C. Betul lah? Confirm. Okay, so C is 1/2 mr squared. So let's use that. The real does not have any lubang kat tengah ni. So yeah, I think the cylinder fits it well. 1/2 mr squared. Jauhnya. Okay, this one. So 1/2 mr squared, the m must be associated to the real, not the bucket, because we are talking about the real over here. So this is 1/2 mr r squared equals to RT. I forgot the alpha, sorry. So this is going to be equal to alpha, and then this is RT. So I want to solve for linear acceleration. So I need to substitute my alpha as linear acceleration. So A equals to R alpha So therefore, alpha is equal to A over R. So let's do that. A over R, okay, equals to R tension. So now let's do our favorite part, which is cancelling out stuff. 1 over 2 MA equals to RT. Betul kan? Sekejap. 1 over 2 MR. Already done this actually, RT. Oh, I have R squared, patutlah. Okay. So this one also cancels out with this R. That was what I was missing. 1 over 2 MR squared, right? So times with A over R. So I'm left with 1 R over here. I have another R over here, so I'm cancelling that out. So now my T is going to be 1 over 2 MA. So that is my T. So the T should be equal because they are referring to the same string, same tension kan, dia tegang kat tempat yang sama. So we can equate these two guys together. I need space. Where should I put it? Sekejap Group. Okay, there you go. So I'm going to equate that. Now we have T and we have T, so we can equate them together. 1 over 2, forgot my real over here. 1 over 2 MRA, they have the same A, hopefully, equals to MB, bucket, G minus MBA. This B is supposed to be smaller. It's not a parameter. MBA, okay? Okay, so I have my A. I know what G is. I know what the mass is. I don't have any radius in my equation, so I'm supposed to be able to substitute. So 1 over 2, mass of real is 5, A is unknown, MB is 3, 9.81 minus with 3, A. So now I'm going to move all my A's on one side. So it's going to be 5 over 2 plus 3. Is it 5.5A? I don't know. 5.5A. 5 over 2, 2.5. 2.5 plus 3 is 5.5. Okay. Equals to 3 times 9.81. Bila tak ada calculator, kena kira dalam otak lah pula kan. Lagi teruk kena. What is 3 times 9.81 guys? I'm going to using my phone. 9.81. So I got
29.43.
Okay, thank you. 29.43. And A is divided by 5.5. So it's going to be 5.35 meter per second squared. Was that hard? Susah tak? Part mana yang rasa susah? I'm gonna let you think a little bit. So I have a chat here. Let me see. Substituting the formula. Oh, the substituting the formula is hard. Oh, okay. Because you had to figure out whether you wanted to use A or alpha. Okay, so that part. Yeah, I agree. Betul. Kalau first time encounter memang rasa susah. Saya rasa susah sebab takut confuse mass real dengan bracket. Yeah, that's actually legit. Ramai orang selalu tertukar. Sometimes they don't write MB ke MR ke, they just write M. So when you get to this part and you don't have the B and the R, it's going to be totally lost lah. Okay, so that is a very legit concern. So knowing you have to make sure you get the right mass. So letak subscript macam ni please put it there so that you are reminded of what it is. And also, if you seem like you're stuck with the equation, always know that your angular quantities can be converted into linear. So for example, A is R alpha, V is R omega, stuff like that. If you find yourself stuck in the equation, you want to solve one unknown, but there is two. So try to figure out macam mana boleh jadikan semua satu unknown je. Okay, so doctor, for the torque, the positive and negative depends on the clockwise or anti-clockwise, right? Yes, correct. So here in our diagram here, they gave us an anti-clockwise because it told us the bucket was going down. If it's going down, dia akan tarik tali tu, and this would be like this, right? So it's rotating anti-clockwise. So I assume that was the case. So it became positive I alpha. Let's say the bucket was going up. Let's say the bucket was going up, right? So your A would be going up here. This guy would be going up, and therefore the rotation has to be clockwise. Then your net torque, oh my God, what is that? Net torque is equal to minus I alpha because it is rotating anti-clockwise. It is rotating clockwise. Tu benda yang kena ingat juga, betul. So the direction, clockwise or anti-clockwise, and then putting the subscript for your masses. The third one is to substitute into linear quantities if you need to. Okay, A equals to R alpha, omega equals to, V equals to R omega. So those are the 3 tips I can give you. Hopefully it will help you. Okay, so A, what is the linear acceleration? This is what we got. So oh, okay. A is 5.35. What is the angular acceleration? We know this is easy. So A is R alpha. If we know what is A and we know what is radius, then it should be a piece of cake. So radius of the real is 0.6 alpha. So how did I know that the radius belongs to the real and not the bucket? Kenapa saya tahu radius ni real, bukan bucket? Anyone wants to guess why? So everyone's scared to answer? Okay. Because the rotation only happens here. There's rotation only happens here. The alpha belongs to the real. The bucket does not rotate. Kalau the bucket rotate, pening kepala lah. Air semua jatuh, tumpah. Betul tak? So only the real rotates. The bucket only falls or goes up. It's a linear motion. So the alpha belongs to the real. Therefore, I know that the radius should come from the real and not the bucket. Okay, so 5.35 equals to 0.6 alpha. So alpha is whatever that is. 5.35 divided by 0.6. 5.35 divided by 0.6. Kejap ada battery, kejap tak ada.
8.9
Oh, thank you. 8.9, what is the units?
RPS.
Hmm?
RPS.
RPS, radians per second. Okay, betul. Radians per second squared. Radians per second squared. Dia alpha. Kalau omega, yes, RPS. So alpha is radians per second squared. Sama macam A. Dia meter per second squared. V, meter per second. Omega is radians per second, which is RPS. Okay, so they are like lebih kurang lah. Okay, radians, meter. Radians, this is red Radians, meter per second per second. Okay. I have a question here. Doktor, if soalan tak diberi diagram, macam mana nak tahu bucket jatuh belah kiri or kanan? Okay, so sebenarnya it doesn't really matter if it's falling this way or the other way because that is a sign convention. If you follow everything as clockwise, jadi negatif, anti-clockwise positif, dia akan dapat jawapan yang sama juga in the end. So let's see, the free body diagram given just now was to the right, right? Let's see macam mana dia solve. Sekejap, that's a good question. How far does what is the tension of the string? So tension of the string, we can use T equals to MBG minus MBA, or we can use T equals to 1/2 MRA. So I'm inclined to use this one because it's shorter. So T equals to 1/2 M real A. So A kita dah tahu. So this is going to be 5 and this is 5.35, and you would get something in the Newton because tension is a force. How far does the bucket drop? So we have A. How far does the bucket drop? So it's asking us what is the S. We already have the U. We have U. We have A. We have T. We want to know what is S. Which equation should I use? Linear kinematic.
US equal UT plus 1 over 2 AT squared.
Yeah, that looks right. So S equals to UT plus 1 over 2 AT squared. Thank you. So U is 0. It started from rest. Plus 1 over 2. Our A is 5.35. What is its direction again? It's going down, right? The bucket was falling. Okay, let me rephrase that. The bucket was falling. This is our A. This was our assumption. And we got our A as 5.35. So what does this mean? It gives, we have a positive value for our A, but the A is going down. What does it mean?
Assumption salah.
Assumption salah. Kalau saya dapat negatif, assumption betul. Macam tu ke? What did I get? T equals 1 over 2 mr squared. T equals to, the other one is minus MBA equal to T minus MBG. Okay, so to answer that question, if your answer is positive, it means your assumption is correct. Itu bukan salah. Kalau dapat negatif, then your assumption is wrong. It means that you need to flip your sign. It's kind of confusing, but that was in chapter 3. And chapter 3 is on your exam. So if you assume your A was going down and you got a positive answer, it means your assumption is correct. It means it is correct. If your A, your final answer, you got it as negative, it means that your assumption is wrong. Therefore, the bucket is not falling, but it is moving upwards. Okay, so that one kena revise balik lah. Okay, because it's critical. So A equals to 5.35 positive. It means our assumption is correct. A is indeed going down. Okay, so betul lah. Kenapa kita dapat 1 over 2 positif betul lah. Okay, dalam kerja saya pun saya dapat positif. So it means the assumption is correct. So, but here in the linear kinematic, we need to take note of the sign. So if it is going up, it is positive. If it is going down, it is a negative. This thing is totally not related to these equations. When we solve for the positive, negative here, we were solving based on the assumption. And like I said to you before, if it is a positive magnitude, then your assumption is correct. If it is a negative, then your assumption is incorrect. This assumption, whatever, dia tak berkaitan dengan linear kinematic. Linear kinematic, apa yang dia nak tahu is dia naik atas ke naik bawah. Itu sahaja. So now that you know that your assumption is correct, you know that your acceleration is indeed going down. Therefore, your A must be negative. So that is going to be minus 5.35. And your T is, it fell for 4 seconds. So that is 4 squared. So 1 over 2 times minus 5.35 times 16 will give you something that is negative. Negative something. So S is negative. Therefore, it is moving down. The displacement is going down. Kalau dapat displacement positif, maksudnya tengah naik atas. So that does not make sense, right? Because we said that the bucket is falling. Okay. So is that okay with everyone? Any questions? Except for soalan Batrisha tadi. Nanti kita akan go over what happens if our rotation is clockwise instead of anti-clockwise. So any questions about this one in particular? The assumption and net Fy, net torque. So that one is okay with everyone? Okay. And again, assumption, make sure you know what it is. Make sure you know what your assumption is and compare it to your final answer. Linear kinematic pula, take note of what are the information that you have. You have U, you have A, you solve from the first part. You know what is your T. So take note of the information that you have and then figure out what equation you can use with these parameters that you have. Okay. So here,
Doktor,
yes.
tadi kan soalan puli ni kan ada dekat topik 3 or 4. Macam mana kita nak tahu kena guna torque ke tak?
Topik puli ni ada dekat apa?
Dekat topik yang depan-depan tu.
Topik depan-depan apa for example, ada tak example yang awak ingat?
Macam forces and motion yang macam puli juga.
Oh, okay. So chapter 3, you mean chapter 3 lah.
Betul.
So chapter 3 we ignored pulley because we did not learn about torque yet, right? So for your exam, focus on chapter 3 without the rotational part. Rotation tak masuk. Rotation is chapter 6, 7, 8, right? So yang tu tak masuk. So please focus on linear motion sahaja. So net F in the X, net F in the Y. Focus on the ramp. How do you resolve the MG? Stuff like that. You don't have to take note of the pulley yet. But the tension in your pulley penting. You don't have to solve for torque, but you need to know if your tension is this one, T1, then this guy should also be T1. What if you have a system like this, a pulley like this? What happens to the T over here? Stuff like that. So tension is penting. Do not completely eliminate pulley just because you won't have the rotational part in chapter 3. The pulley is still much very important, but in tension punya sense. Tension is a force, right? So find out pulleys of different styles, not just the single one, the 2, 3 types yang ada tali banyak-banyak semua tu. Figure it out into how to draw the free body diagram of those types of pulleys. Penting penting. Okay. Any other questions before we go over this one? Okay, I'm going to continue. If you have any questions, just interrupt me. So here, instead of assuming that this guy is moving anti-clockwise, they are drawing the free body diagram the other way. Tapi the bucket is still falling. So sebab let's say gambar ni tak wujud So you draw your picture like this. Betul, tak salah pun. Because they didn't give you diagram, so you don't have to follow anything. It's just based on your imagination yang logic. So this is logical, so it is correct. So this one, it is rotating clockwise, and this guy is falling, right? So it has acceleration that is going down. So this one, pasal dia patut buat negatif. So torque, dia tak buat condition dia cara dia lain sikit dari saya. Net torque is equal to minus I alpha, and since our tension is moving this way, it is pulling the reel clockwise. Therefore, the equation should be minus T minus R minus capital R T. So this would be equal to your condition that you wrote up here, and it is equal to I alpha minus I alpha is equal to minus RT. So you can get rid of the minus signs because they are on both sides. So it becomes I alpha RT. Sama tak macam tadi? Oops. Where is it? We got I alpha plus RT at the end. So sebenarnya you will get the same answer walaupun your direction is flipped. Okay. So that's kind of confusing, right? But tak apa, just follow whatever diagram that you have that is logic. Okay. Kalau dia kasih diagram, use that diagram. Jangan lukis diagram lain pula. Jangan rajin sangat. Okay. So this is torque equals to R alpha, sorry, RF is equal to I alpha. So they don't use the condition system macam kita buat. Diorang terus equate je, boleh juga. RT is equal to I A over R, terus substitute alpha ni as A over R, and then baru dia substitute for I, 1 over 2 mr squared, AR squared. So cancel out, you get 1 over 2 mr A as your tension. The same thing that we did. And then dia tak solve for, dia shortcut lah, dia buat banyak shortcut kat sini. So dia cakap MBA, A is going down but they wrote it as positive. Boleh. That is the convention that they want to go with. Boleh. So MBA going down, assumption positive. MBG, kau tengok sini MBG going down. Semua yang jatuh ke bawah, all forces going down will be a positive. Walaupun you weight, because this is the convention that you wanted to go with. Going down as your positive. This one going down, positive. MBG. Therefore, your tension will be negative. Tension will be negative. So minus T, the T, they substituted this guy. Minus 1 over 2 MRA. And then they solve it, they got 5.35. They got a positive answer. Assumption is correct. Assumption is correct. Walaupun convention sign orang lain. What it was the assumption? The assumption was going down. A is going down. Betul. Okay, so I hope that is okay for everyone because yeah, convention sign memang macam pening kepala sikit. Tapi just stick to one. You will be fine. Okay, jangan pening-pening kepala nak buat banyak-banyak. Nak buat convention bawah positif, betul nak buat convention atas positif. Just stick to one. You will be fine. Okay. Okay, do we get the same answer? We did. This one was correct. I don't think we calculated for this one and this one, but that's okay. Dia punya jalan kira sama. Okay. Habis chapter 8. Yay. So let's take a mini break. Let's take 10 minutes. Come back at 11:52. Okay. Kita akan discuss exam around like 30 minutes or less, just like overview sahaja. Okay. Stop share. Please take your rest and come back. Okay, let's continue. Hmm. Okay, is everyone back? Hopefully everyone is. It's already 11:52. Okay, so let's talk about the exam. So the exam is going to be 1 hour and 30 minutes. Okay, 1 hour, 30 minutes. My God, listen. It has 3 chapters. Therefore, you would have 3 main questions. Okay, so for example, you have question number 1. It has A, B, C, let's say. It is, all of this question is from chapter 3. Sama juga question number 2, all of it is chapter 4. Oops, chapter pula. Chapter 4. And of course, chapter 3 pun semua yang ABC under number 3 will be chapter 5. So those are your 3 questions. And then we are using WebAssign and you will have to key in your final answer. However, you will need to show us your working step. So you would have to prepare an A4, several A4 papers or like 5 pages of A4, depending on how big your writing is. So you write your name, your metric ID, and then ASP 0504, penilaian, whatever, number 2, yes, plan number 2. And then start with your question number 1. Don't copy the questions, just write down your working steps. So let's say you are doing chapter 3, net in the fx is equal to MA. What is in the free body diagram? You write that down. Semua kena tulis. Let's say you write them all and, sorry, MA, T minus MG, contoh Let's say you get the first condition wrong, but your equation for your other net in the FY is correct. I would still consider this as correct. Walaupun jawapan for the entire question is wrong, but you get parts of it correct. This one is wrong, this one is wrong, this one is right. I will still give you marks. So writing down your complete working step is very, very crucial, very, very important for me to help you get marks. I want to give you marks. I don't want you to fail. Okay, so that is how you write down the working steps. Please do that for all. If they ask you to draw the free body diagram, then draw the free body diagram correctly. Start with the center of mass, G, R, whatever lah, friction. Okay, draw the free body diagram correctly. You don't have to draw the object. Let's say the object is a diamond. You don't have to draw that diamond. Just draw this thing. Okay, if it's moving, indicate acceleration if it is. If it's not, then don't write anything. What else about the exam? 3 questions. Write down everything. So how will you submit your working steps, right? You need to have an app that is able to scan your PDF. After you scan the PDF, you need to be able to send it to Putra Blast. You uploaded it on Putra Blast. Remember how you upload your working sheets for labs? The same way, you save your working steps as PDF and then upload it to your Putra Blast, to our Putra Blast lah. Doctor, can we write the answer using pencil? Yes, boleh. Because later on you will PDF it. So it's basically written in stone dah lah. You can't change it. Previously, you can't use pencil because there was a tendency for you to rub it off when you get back the papers. You won't get back the papers. The paper will be with me. You will have the copy of it in the PDF form. So boleh pakai pencil kalau nak. But make sure when you scan it, it is readable. The contrast is there. If I can't read your handwriting, I cannot give you marks. Okay, so please make sure your handwriting is neat and readable, and when you scan it, I can read it. Okay, so that is that. Upload your PDF on Putra Blast. Final answer is in WebAssign. Doctor, can we write the answer using tab? Yes, you can. As long as you can give me a PDF, I am okay with that. Any other questions? Okay, so when you have a tangkap gambar pakai PDF, so if you are using iPhone, there's an app for that. There's no app. You have a built-in app for that using Notes. So how do I show this to you? So if you're using iPhone, untuk Android nanti saya akan cakap. If you're using iPhone, you go to Notes. Okay, you go to your Notes, search Notes in your iPhone, and then you have that, dah tak nampak. You have that sign, kejap Gonna show you guys. Kalau tahu baguslah. I'm just showing this for people who don't know. Okay, scan documents. Okay, done. Save the photos. I'm gonna share this in class. Okay, 19. Okay, so if you go to Notes, you click on the camera icon. There is an option to scan documents. You can scan using that. And then after you scan your answers, send it to yourself via email or apa-apa cara lah, AirDrop ke if you have a Mac, email if you don't have a Mac, and then from your email, download and send it to the Putra Blast. So you know that there are many steps to scan and then upload and then go to the Putra Blast. So we will give like extra time of 10 minutes, but I'm not sure yet about this one. I will let you know. 10 minutes hanya untuk this uploading process. I will let you know on this one. If you are using Android, I believe the app called Cam Scanner is available and free to use. Typically, my students use Cam Scanner. Not sure if you guys have a better app than Cam Scanner, to be honest, but sebab tak pernah pakai. So Cam Scanner, and also use your Notes if you're using iPhone. So iPhone, pakai Notes. If you have like a legit scanner, then use that. Android, pakai Cam Scanner. Please try to use it. Figure out how long does it take for you to upload your document and how can you get it to Putra Blast. How long does it take you? So please plan for that. Cam Scanner. Ya Allah, kenapa tulisan ni? Macam worms. Cam Scanner. Tahu tak, waktu saya kecil kan, saya pernah kena tolak markah sebab tulisan saya buruk sangat. Sampai sekarang saya ingat sebab sedih. But anyways, I won't penalize you for bad handwriting, but I need to be able to read it, okay? Doctor, if the answer is slightly different with answer scheme because we use 9.81, but the web assign uses 9.8, our answer is still correct. Okay, so for your information, we are not using questions from web assign. Walaupun kita orang pakai web assign, the question is from us. We code it into the web assign. If you don't know, we code our questions in web assign. So our answers will be based on our own answer scheme, which is 9.81 lah. So you don't have to worry about web assign punya constants because we code our own questions. Doktor, nanti masa exam kena masuk Zoom dulu ke? Tak perlu. Please go to your web assign directly. There's no Zoom session. I am trusting you guys to not copy each other. You are on your own, but please be truthful to yourself. This is to really know what is your level of understanding, whether you get it or not. So don't copy each other. I'm trusting you guys. We don't have to have a Zoom session, okay? What else? So scanning, uploading to Putra Blast, PDF sahaja. Boleh pakai iPad. Boleh pakai iPad. Boleh pakai iPad. Doktor, kita punya jawapan kena berapa significant figures? Significant figures saya tak sure, tapi kena ada 2 decimal places. 2 decimal. Kenapa ni? I can't write. Kejap. Okay. Right. Answer should be, oh my god. Kejap. Or is it time to have an iPad? I'm getting frustrated over this. Answer must be 2 decimal places. Significant figures, I don't know, maybe 3, maybe 4. But 2 decimal places wajib. Berbeza dua tu. 2 decimal places. Okay. Doktor, sekejap. There's another question here. Doktor, kalau physical test, formula selalunya dibagi atau kena hafal semua formula? Kalau physical test, you have to memorize the formula. Which I don't agree with, tapi that is the system that they use. You have to know the formula. Yeah, you have to know the formula. You have to memorize the formula. So kalau physical test, okay. So I don't agree with that because I feel like to test your understanding, it doesn't have to involve memorizing the equation. But itu memang sistem yang orang pakai dari dulu. So we have to follow that. Any other questions? Formula is not given. Okay, but constants are. Constants are given. Tadi tulisan saya tak buruk macam ni kan? I don't know what's going on. But constants are given. For example, chapter 3 ada constant ke tak? Chapter 4, chapter 5. Chapter 5 apa? Chapter 5 impulse. Tak ada kan? Constant tak ada. Okay, yeah. There's no constant. But if there is, it will be on the exam. I mean, it will be given to you guys in the question. Any other questions? So again, always remember to write down your steps. If you are using your calculator, write down what you are putting in your calculator. Jangan terus tekan terus dapat jawapan. I can't give you marks if you get it wrong. Kalau dapat jawapan betul pun, dapat 1 markah je daripada total marks. Sebab final answer jawab dia punya markah 1 saja. Working steps tu yang dapat markah lain-lain. So don't just write the final answer. Okay? And then after you have written down your working steps and your final answer in your PDF, in your paper, write down the final answer in your web assign boxes yang ada tu and then click enter, submit before the time is due. It is important to me actually. So for your final answers to be there. So saya boleh project. Do you guys need more time or is the time enough? So benda-benda macam tu penting lah untuk macam masa kecemasan ke apa ke. Please indicate dah siap ke belum in that because saya boleh tengok siapa yang dah jawab kat situ Okay, what else Okay, for your revision, I already assigned a revision exercise. So let's go to that. If you want to do it, it's not wajib. It's not mandatory for you to do it, but if you want, my battery is dying. If you want to do it, by all means, please do it. It will help you. I'm sure of that. Mana ada orang tak nak buat soalan lecturer kasih kan? Ada ke? Tak tahulah. Okay, tutup mata. Just kidding. It's not there. Okay, so I already assigned you guys a revision exercise. It's called revision chapter 3 to 5. Okay, so the settings that I used here is, edit settings, submissions allowed 5. Okay, so after 1 try, you will get hints and tutorial. Practice another version is after one try. Let's say you get the answer wrong, you will get the practice another version. I'm sure you know this already because this is the typical setting for your web design. The answer key will be given after 3. I'm setting this to 3. Let's say you answer 3 times and you still get it wrong. The answer key will be given to you. The solution will also be given after 3 tries. This one tak kisah. And then, so let's say you are in a hurry, you try it one time and you got it wrong and you want to know how to do it, what is the solution, you can just enter it 3 times sampai dia habis that 3 submission that they give you, and then the solution will pop out. So that is macam my study guide for you, okay? So let's see the assignment. So we have this chapter 3 ada, chapter 4 ada, kejap. So there are typical questions that you would do from your web assign from previous chapters. I'm just putting it back in this one because I think it is relevant to your exam. Okay, some questions are not in your previous web assign, some are new because I think they are important. So please do that. Ada yang repeat, ada yang baru. So try your best. The solutions are there after 3 attempts. If you still don't understand, you can ask me. Discussions are most encouraged. Okay, if you have anything to discuss, discuss in the group if you want. Discuss with your friends. There's no copying here. It is not mandatory to complete it. It is up to you. If you want to do it, you can do it. If you don't want to do it, you have a better method to revise your exam, revise for the exam, just go for it, okay? So this is my revision for you guys, okay? Okay, that is it. If you have any questions, let's say you do the revision and you're stuck at a question, even though you have the solution. You want to ask me, you can ask me tomorrow. We have class if you have questions. If you don't have any questions, we can cancel class. And you can continue your revision on the web using the web assign. Doctor, can we use the test pad yang ada garis tu? Yes, you can. As long as you can give me PDF form, I'm okay. Periksa ni pakai physical atas kertas, lepas tu ambil gambar. Yes, correct. Correct, Iqbal. You have to scan your physical paper and upload it if you are using paper. If you are using iPad, then you submit it as a PDF. Whatever surface that you use, test pad ke, blank A4, iPad, as long as you can send me a PDF, you are good. You can use it. You can write using a pencil. You can write using a pen. Boleh, apa-apa saja. Okay, so that is it. If you want to ask me questions tomorrow, make sure you do the revision today. So you can ask me tomorrow. We won't have class on Thursday. I'm letting you guys revise for your upcoming exam. I think it's chemistry. Yeah, so esok boleh tanya soalan kalau ada. Okay, so bye guys. Have a good revision and all the best. I will always be praying for all of you. I want you guys to succeed. As long as you're doing your best, that is enough for me. So jangan panic. Just try your best, okay? So bye-bye. I'm always available if you have
Thank you,
questions.
Doctor.
Bye.
Thank
you,
Thank you, Doctor.
Welcome.
Thank you,
Bye-bye.
Doctor.
Thank you, Doctor.
Welcome.
Thank you, Doctor.
Bye. Welcome.